presenting here mathematical modeling, and the sub-theme is toy technology, toy pedagogy and methodologies. Welcome to my models. So first of all, we must know what is mathematics modeling is all about. Mathematical modeling is taking a physical situation and then introducing it to a mathematical model, mathematical solution, then solving mathematical solution. If the solution of the original problem after interpretation, if it is in a good agreement, we will accept the model. If it is not in a good agreement, we will modify the hypothesis. Again we reassume the physical situation, and then we will again go for this. This is all about. Suppose you are planning for a house, construction of a house. Then it's a kind of mathematical modeling. The solution, whether that is feasible, that the area is feasible nearby to all these public facilities, amenities are available or not. Okay. Then after that, whether you can get the loan, whether that land is either disputed or a very legally it is very good, and bank can come and offer loans, and solution for the original problem. If it's not in a good agreement, then we will not accept the model. If it is in a good agreement, then we will accept the model. That is why every act of ours, every deed, whatever we carry on, either on the national level or the local level or in the individual level, it's all about mathematical modeling. It's a planning. It's entire based on planning. That is what we call it, mathematical modeling. Now coming to our sub-theme, it's a very, very phenomenal theme, that is toy technology. So we are part of that toy marathon, toy fair, and we have found that how immensely our toys can play a very vital role in our day-to-day life and in our educational aspects. Therefore, simple toys I have brought for presenting here as a toy technology. First of all, when I take these 4 stripes, this is changing shape. Okay, but loosely tied 4 strips changes the shape very easily. But once I take this one, the triangular, 3 stripes are fixed. Even if loosely fixed, I cannot change the shape. This is what feeling mathematics. I have felt mathematics, and that is why these triangular structures are widely used in construction tower, in construction bridges, in construction everywhere. These triangular structures are used. Similarly, if I take a tripod stand, you can see these tripod stands we are using in our lab, and it is also widely used by the photographers and survey people. Why these triangular structures, tripod stands are very, very familiar with photographers and survey people, I will let you know. I have taken another tripod stand whose, legs you can see, these legs are uneven, not of equal length. I have cut not in equal length. Even then, see, it is firmly standing. It is firmly standing. Because the reason is purely mathematical. Through any 3 non-collinear points, only one plane can pass through. That is why tripod stands are widely used by survey people and photographers. This is one of the best mathematical modeling toy which can be used as a toy. Now coming to, when I say A4 size paper I have taken. A4 size paper, if I want to I make a hole like this so that the whole of my body can pass through it. So it's not possible, it seems, it's not possible. But once you fold and cut in a structural way, that you see, from the same A4 size paper, I have cut and entire body can pass through. This is my next thing. And one of the most interesting thing, mathematics is not confined to mathematics. Mathematics can be integrated to different stream of studies, different sphere of studies. So for example, suppose I would like to say science. See how symmetrical this skeleton is. How symmetrical and how enjoyable this can be used as a toy. The children will learn very nicely. This is what very interesting model can be created because of mathematical symmetry and educational toys. This can be used very nice manner, interesting manner. Now coming to how to change two-dimensional solid into three-dimensional solids. You can see I have a shape here. One part of the eye, one part of the ear, one part of the mouth is seen. And if I revolve it, I get the whole body. If I revolve it, I get the whole body. Whole face can be visible. So this is drastically changing the two-dimensional into three-dimensional. Now coming to my one more model, which is very interesting, phenomenal. See, I have a triangular region filled with 5 strips, filled with 4 strips. 1, 2, 3, 4. 4 strips. I have one more, please. If I want to insert it somewhere here, no space, I cannot fix it because the area of this triangular region is fixed. But let me see whether I can do it. If I remove these stripes, I have moved this triangular shape here, I have fixed it here, and then I am getting this triangle here, and I have a stripe here. Yes, let me fix this one here, and then this one here. Okay, this I will take to this side. Okay, now I am fixing this. This is 4 strips. Okay, now I want to fix the 5 strips. So I will bring this part of the triangle here, and then I will fix this one. Done. And then this one is done nicely. 1, 2, 3. 3 is done. Then 4th place I am fixing here. Oh my God, I got this place. So it is fixed with 5 strips now. This is the amazing technology in mathematics, magic in mathematics, which one can display. Now finally, how mathematics can be useful for sustainable growth of our country, for sustainable growth and protecting our nature as well. Say for example, there are 4 trees in this field in a systematic manner, in a straight line. In fact, they are. All the trees are here, and it has to be divided among 4 persons, equal area, and without cutting the trees. Without cutting the trees. Is it possible? Say for example, for dividing lands, we are mercilessly cutting the trees. We are spoiling our nature, which is very inhuman, and we are also affecting that violent act towards the whole ecological balance of this whole globe. So we can also, through mathematical modeling, without cutting the trees, in this way we can cut the land areas without even cutting the trees. Each one will be divided, getting the same equal amount of land, and will be blessed to have a tree as well. Thank you very much. Thank you very much for my mathematical modelings.